Okay, thank you very much for the opportunity. My name is Javier Toro. I'm the president of Simple Science Education. I'm going to talk about this study that we will be conducting starting in a couple of weeks until the end of the year, which is exploring teachers' readiness to adopt the simple science approach to teaching and learning in physics. Next slide, please. Hello. Yes. So the purpose of this study is to teachers' readiness to adopt the innovative approach to teaching and learning physics in K-12 education that we have been developing at Simple Science. The findings will help us understand teachers' readiness for innovative practice and to identify actions to be taken in relation to the approach and professional development. Next, please. So this approach to teaching and learning is a form of technology. Among other things, technology refers to the application of knowledge, skills, and techniques to modify or improve processes. And this is what this approach does. The approach is a question and answer method to arrive at physics concepts and equations through experimentation via interactive simulations that mimic the scientific method. This approach mimics the scientific method in that trials and modifications, core elements of the scientific method, are kept to a minimum. This is achieved by making use of all that we know about the fact to be established, which may include knowledge of the subject to be taught and knowledge of general teaching strategies. Simulations, which are computer-based representations of models of real world processes or systems, play a significant role in enabling and facilitating this approach. The approach could still be applied without them, but it would be too time-consuming to provide a real alternative to traditional lectures. Next slide, please. So let's talk about the scientific method. The scientific method involves careful observation, the formulation of hypotheses, the testing of the inferences drawn from the hypothesis through experimentation, and the refinement of the hypothesis on the basis of the experimental results. So it is a method of trial and modifications, which in this diagram is represented by the loop on the top of the whole slide. Knowledge of the fact to be established allows us to streamline the trials and modifications through guided exploration. For example, we can guide students towards the correct interpretation of phenomena and direct them to relevant experiments that confirm those interpretations. On the other hand, making observations can be time-consuming due to several reasons. One factor is that accurate and precise observations demand meticulous attention to detail, which adds to the time required. Likewise, conducting experiments can also be a time-consuming endeavor due to several factors. For example, there's the possibility that the initial procedure might not yield the desired outcome, requiring troubleshooting and adjustments, which is represented in this diagram by the loop at the bottom of the slide. So simulations can reduce the time required for making observations and conducting experiments. Simulations can be designed so that only the relevant variables are involved. Next slide, please. So let's examine an example to grasp how knowledge about the fact to be established can be exploited in a system comprised of two masses, if M1 and M2, if L1 is the distance of mass 1 to the center of gravity of this system, and L2 is the distance of mass 2 to the center of gravity of the system, then the masses and the distances must satisfy that equation on the top, M1 times L1 equals M2 times L2. That's the equation we want to arrive at from experimentation in this example, which is this figure here shows three different configurations of the masses, and those can be obtained experimentally. So what the results, the experimental results gives us when M1 is equal to when M2 is equal to M1, then L2 is equal to L1. That means that the center of gravity is halfway between the two masses. Now, when M2 is 2 times N1, then L2 is L1 over 2. It's closer to the center of gravity is now closer to M2. And when M2 is equal to 3 times M1, then the distance L2 is equal to L1 over 3. So those are the experimental observations which we can get from simulations. Now, how to go from those observations to that equation on the top? Next slide, please. I will skip that. This is another way of getting the same results from only 2 observations, which are shown on the left of the slide. Next slide, please. So we see here when from the experimental results we obtained, when M2 is equal to 2M1, L2 is equal to L1 over 2, and when M2 is equal to 3 times M1, L2 is equal to L1 over 3. So that shows that as the mass increases, the distance of the mass to the center of gravity decreases in the same proportion. That means that L2 is inversely proportional to M2. That two quantities are inversely proportional means that their multiplications is always the same, it's a constant. And that's how we go from these experimental observations to the equation at the bottom of the slide. So the approach, basically, what we have to do is to get some observations to find out, and then we have to explore or get the relationship or pattern from the observations, and then we have to know how to write that pattern or that relationship in a mathematical form, and that's how we go from observation to equations. So next slide, please. How to apply the approach? But first we have to construct a sequence of questions and answers in a way that leads the students to the correct conclusion. Once we have those questions and answers, then we can make an introductory presentation so to help students understand that what will come next. Then we ask one question at a time and let the students reflect and come up with an answer. Then we let students compare the answer with the one prepared beforehand. This will reveal to them the strengths and weaknesses of their responses. It will help them identify misconceptions. It will expose them to ways of seeing and things that they may not be familiar with. And also, the last step is students must be encouraged to reflect on the reasons for each question. This will help them develop their questioning skills. Next, please. So what are the benefits of this approach? Compared to traditional lectures, this approach can promote a deeper understanding of concepts and the meaning of equations. Derivation from experimentation can illuminate why and how concepts and equations capture what they represent. Unlike a verification, for example, plugging in values into an equation to see if they add up, a derivation can reveal the motivations and limitations and subtleties involved in that representation of a phenomenon. And compared to active learning techniques, which have been shown to significantly enhance students' learning experiences, this approach can address some of the limitations, such as time-consuming implementation, increased cognitive load for teachers in the classroom, and reduced coverage of content. And this is done by allowing for systematic planning, preparation, and reuse of lessons. So once you have your questions and answers prepared, you can reuse them as many times without without any modification practically. Next, please. So to carry out this study, we'll rely on the unified theory of acceptance and use of technology model. This model was developed to understand and explain individuals' acceptance and usage of technology. The model has been widely adopted and extended in various studies to examine technology acceptance across different contexts and technologies. It serves as a valuable framework for researchers and practitioners in understanding the factors that drive technology adoption and usage. The model identifies 4 key factors that influence individuals' behavior, individuals' intention to use technology. The first one is performance expectancy, which is the degree to which an individual believes that using the technology will enhance their job performance or effectiveness. And effort expectancy, the perceived ease of use and simplicity associated with using the technology. Social influence, the impact of social factors such as social norms, such as subjective norms and social support on an individual's intention to use the technology, and facilitating conditions, the extent to which an individual perceives that the necessary resources and support are available to use the technology effectively. Next. Additionally, the model recognizes 3 moderating factors that can influence the relationship between the aforementioned factors and behavioral intention. Gender, which refers to differences in technology adoption and usage based on gender. Age, variations in technology acceptance and usage influenced by age-related factors. Experience, the influence of prior experience with similar technologies on the acceptance and use of new technology. Next. Now, on data collection, I would like to take this opportunity to invite all interested secondary school physics teachers in grade 11 and 12 to participate in this study. And I encourage you to share this invitation with your colleagues and invite them to join as well. Your assistance in spreading the word about this study will be greatly appreciated. Next. So about the instrument, it's a questionnaire based on on this model, and it will be available on the dates on which it will be administered. Questions offer a 7-point Likert scale, ranging from strongly disagree to strongly agree, to allow respondents to indicate their level of agreement and disagreement with the given statements. There is a section at the end of the questionnaire for comments, and the questionnaire is to be filled out online only. Next. Regarding the study, teachers, how it will be conducted. Teachers do not have to spend their time and effort creating lesson plans based on the approach. Instead, they will have access to ready-made activities and materials prepared by Simple Science, which they can use during the study. And this allows teachers to focus on participating in the study rather than investing additional time and effort into lesson preparation. Every teacher as well will have an anonymous account that they can use to grant the students access to the resource. This account will allow teachers to provide their students with access to the without revealing their own identities or personal information. Next. As I said before, the questionnaire will be administered on 2 occasions: before using the approach in the classroom on the 9th of June, and after the use of the approach in the classroom on the 21st of December. And you can sign up to the study using this link at the bottom. Please sign up before by the 6th of June. And I think that's about my presentation. Thank you very much.